Hello everyone, welcome to In 5 Minutes. In this video clip, we'll discuss one problem on series parallel connection of resistors. You are given one circuit where you have to find out the equivalent resistance between nodes A and B. And you can see there are a lot of resistors in this particular circuit. So basically till now all we have discussed is what happens when two resistors are in series, that means what is its equivalent resistance, and when two resistors are in parallel, what is the equivalent resistance. So we will try to look for such type of combinations in the circuit. So if you give a quick glance to this particular circuit, you can make out that this 15 ohm and this 10 ohm resistors, they are in series. This 10 ohm and this 14 ohm resistors are also in series, and this 20 ohm and 30 ohm resistors are in series. So the very first step that we can go for is club this three pairs of resistors considering the series combination. So let's draw the new circuit that we are going to get. This is the first resistor which will have the value of 10 ohm. These two branches I'm not going to disturb, I'll just keep them as it is. Here also we have resistance of 8 ohm, nothing changes there. This 20 and 30 ohm in series will add up to 50 ohm, so let me take 50 ohm here. Now this 40 and 10 ohms will also be added to give us 50 ohm resistance here, and this 15 plus 10 will make it equal to 25 ohms. So these are the series combinations that we have gone for: 25 here, 50 here, and 30 plus 20, 50 here again. Now you can see that no two resistors are in series combination, so we'll have to look for if there are any parallel combinations. So parallel combination, you have to remember that two resistors are said to be in parallel when both the ends are shorted together. If that is the case, they are said to be in parallel. Now let us see what are the ends of this 50 ohm resistor. This 50 ohm resistor has one end here, let me call it as X, and one end here, let me call this as Y. Now this whole line will be nothing but node Y, simply because there is nothing else connected, no other component connected on this line. So even this point is point Y. You can see 50 ohm is connected between point Y, and the other end of 50 ohm is also going to Z. So you can see this is also point Z because nothing else is present on this particular line. So 50 ohm is connected between X and Y like this 50 ohm. So both this 50 ohm resistors are in parallel. Let us see what are the two ends of 25 ohm resistor. This 25 ohm resistor has one end here. Now this end goes down to meet node Y. So this end is node Y without a doubt, and the other end from here goes ahead to meet node X. So this point is X again. This concludes that 25 ohm is also connected between Y and X. That means all these three resistors, 50 ohm, 50 ohm and 25 ohm, are connected between two nodes or two ends which are named as X and Y in this particular circuit. So that means all the three resistors are in parallel. So if I redraw the circuit, so parallel combination becomes very much visible in that case. So this is my node X, so I'll just mark it as X, and I'll show node Y somewhere here. So this was, you can see this end of 10 ohm is node Y, so I'll just show Y here, and between X and Y we have basically three resistors available. So total three resistors, they come in parallel. Let me call this as 50 ohm. This is first 50 ohm resistance, second 50 ohm resistance, and the third resistance here was 25 ohms which comes here. And the original two resistors, this is 10 ohm and this is 8 ohm, will remain as it is. This was my node A and this was my node B. So let us now find the parallel combination of these three resistors. 50, 50 and 25 in parallel will make it one single resistance. So this resistance is of 10 ohm. From here you have 8 ohm resistance available like this, and finally these three resistors combined will only keep one single resistance here. So this resistance will be nothing but 50 in parallel with 50 in parallel with 25. Now we all know that when the two resistors of equal value are in parallel, the equivalent resistance will be half of the original value. So 50 parallel 50 will make it 25 in parallel with 25. Again, two resistors in parallel of the same value, so the parallel combination will be half of the original value, that will be 12.5 ohms. That means between A and B, therefore the value RAB becomes, it will be 8 plus this 12.5 ohm resistance plus 10 ohm resistance. So all these three resistors added gives me my final answer, which becomes 30.5 ohm.